the perfect answer. So this integral has a really nice answer, minus 1 by 2, and then si square alpha beta plus ci square alpha beta. This was too awesome to not to include in this video, and so I did. Yeah. And if you don't know about this function, let me just give you the definitions. Si of x is just negative of the integral from x to infinity sine t by t dt. Yeah. And ci of x is again negative of the integral from x to infinity of cos t by t dt. Yes. So these two are the definitions that we have made. Yeah. Now let's try to solve this problem. Okay. So for the first thing that we might want to do is to simplify the ci function by changing to cos. Yeah. So for that we can first take I of alpha as these things and then differentiate it. Yeah. If we differentiate, we get I dash of alpha as integral from 0 to infinity. This is cos alpha x by alpha x. Yeah. And then since we have alpha with x, since we are differentiating with respect to alpha, x is constant, so we have to take it out by x plus beta. And these are just constant because we are differentiating with respect to alpha dx. Now cancel the x's and we have integral from 0 to infinity 1 by alpha cos of alpha x by x plus beta dx. Okay, now the next step is all kind of obvious. Just we have to let y equals to x plus beta. Yeah. And we get I dash of alpha as 1 by alpha. This is from beta to infinity, and then cos of alpha times, and x is y minus beta by x plus beta. X plus beta is just y, and then dx is just dy. Yes. So we get I dash of alpha as 1 by alpha, and then is this integral from beta to infinity? Yeah. Beta to infinity. Beta to infinity. Now this will be cos A cos B plus sin A sin B. Yeah. Yes. And divided by y dy. Okay. Now next we have I dash of alpha as 1 by alpha. And how did I write alpha over here? It's not alpha, it's infinity. Yes. Now good. Integral from beta to infinity, and please notice that cos alpha beta is just constant now. Cos of alpha beta is just a constant. Now this is cos of alpha y by y dy, plus similarly we can write over here also sin of alpha beta is constant. Yeah. And the integral from beta to infinity, yes, sin of alpha y by y dy. Yes. And this closes. Now we can see that if we d of alpha y is just alpha times dy. If we can also place alpha over here, and these two cancel out. Yeah. Similarly, you can place alpha over here and d of alpha y, and this alpha will cancel out. So let me do that. Let me do that. Okay, wait for some time. Yeah, I think I'm sorry for this wait. Okay, due to some internet issues, we have traveled back in time. Yeah, and we have to do it again. Integral from beta to infinity. We have sine of alpha y by y and then dy. Yes. Now what I was saying is we can basically place alpha and alpha over here, because d of alpha y is just alpha dy. The alpha cancel over here. Yeah. Similarly also over here and here. Yes. Now what we can do is basically let g is equals to alpha y, change of variables. That gives us idence of alpha as 1 by alpha, and then over here cos of alpha beta, and with this change of variable we have alpha beta to infinity cos g by z dg plus sine of alpha beta, and then this is from alpha beta to infinity sine of g by z dg. Yes. Now we know that the definitions of the integral functions, yeah, I think I said earlier in the beginning of the video that we have a negative sign over here and the x is the beginning point. Yeah, so we have to care for those two things. X is the beginning point and the negative sign should be there, which is not there, so we have to place that in answer. Idence of alpha will basically be 1 by alpha. Yeah, and then cos of alpha beta, this will basically be minus cos ci of alpha beta. Yeah, and then next is plus sine of alpha beta, this will be minus si of alpha beta. Yeah, now let's take the minus sign outside. Idence of alpha will be minus sign over here, and then ci alpha beta cos of alpha beta by alpha plus si alpha beta sine of alpha beta by alpha. We have this. Yeah, now we can take remove the derivative and write this as di, just di. Basically we can just and then by d alpha goes to other side, so I will basically be I of alpha will basically be its integral, yeah, with d alpha. Now again here's a kind of similar thing. I of alpha is equals to minus, yeah, now this integral will basically be ci of alpha beta. Yeah, and now the derivative of ci of alpha beta will be basically cos of, with respect to alpha if it is, so cos of alpha beta by, and here it's alpha, isn't it? We can write this as alpha beta. Now d of beta alpha, can you do that considering b as constant? Yeah, because it's in the world of alpha. Yeah, b comes out, b cancels out, so yeah, we have this thing. Yeah, similarly over here, so we can do the same thing. Si of alpha beta, over here we can write this as sine of alpha beta. Now alpha beta and then d of beta alpha, because beta is constant, it will come out and cancel. Yes. So now what I want to do actually is if we let let's say g, yeah, if we let's say g as beta alpha, yeah, over here alpha is the variable. Yeah, if we let g as beta alpha where alpha is the variable, we now have I of alpha as minus of integral of Cig, yeah, and then this is just the derivative of the Cig, yeah, cos alpha beta by alpha beta, and then d of beta alpha. This is just derivative of Cig, yeah, and over here we have Sig, and that is just derivative of Sig. So now in this case we know what to do. This is just kind of y dy thing, which is y square by 2. That's why we get I of alpha as minus of Ci square g plus Si square g by 2 by 2. Yes. Now that is minus 1 by 2. We know that g is just alpha beta. So Ci square alpha beta plus Si square alpha beta, and that is the answer. Yes. So it's pretty long, but it was pretty interesting as well. Let's see if it's the answer correct or not. Minus 1 by 2 as a square alpha beta plus, okay. So answer is correct. The only thing that we need to have known is definition, and then substitution, and there again with the definition as well. Just some but good manipulations. Again with the definitions and normal integrations, substitutions, and yeah, that give us the answer. Hope you enjoyed the video. Thanks for watching, and look forward to seeing you in the upcoming videos too.